Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count total number of colored cells. So the problem states that there exists an infinitely large two-dimensional grid of uncolored unit cells, and we are given a positive integer n, and we want to return the number of colored cells at the end of n minutes. So what will happen is at the first minute, we will color one cell blue, and every minute thereafter, we will color every uncolored cell that touches a blue cell blue. So in the beginning, after 1 minute, we'll have one blue cell. After 2 minutes, there are 4 cells that touches this one blue cell, so it will become 5 blue cells. And after 3 minutes, there will become 13 blue cells based on all the uncolored cell that touches a blue cell. So now that we have seen some examples, let's get to how we can solve this problem. So if we notice a pattern after 1, starting at n is equal to 2, at every iteration, it will add 4 times n minus 1. So as you can see, n equals 2, it will be 5. n equals 3, it will be 13 because we are adding 4 times n minus 1, which is 4 times 2. So 5 plus 8 is equal to 13. At n plus 4, we are adding 4 times 4 minus 1, which is 4 times 3, which is 12. So 13 plus 12 will equal 25. So if you count up these blue squares, it will be 25. So if we notice this pattern, then we can use this code to find our solution. So we will just loop through n, and at every n, we will multiply by I. We will loop from 0 to n. And this approach, we can solve it in O of n time, but there's actually a more efficient way to solve this problem, and I'll go over that way right now. So to solve it more efficiently, we should know the Gauss formula, which is the formula to find the sum of an arithmetic sequence from 1 to n. And if you look at this problem basically follows the Gauss formula starting at n is equal to 2, except that we need to multiply each iteration by 4. If you still don't see it, let me show you this example when n is equal to 4. So basically we're doing 1 plus 4 times 1 plus 4 times 2 plus 4 times 3. And we can just put 4 on the outside, multiply by 1, 2, 3. So the Gauss formula basically starts at n is equal to 2. And for n is equal to 1, we just add 1 on the outside. So coming back to the formula, we basically do 1 plus 4 times the Gauss formula. But instead of doing n times n plus 1, we do n times n minus 1 since we are starting at 2 instead of 1. And we can simplify or derive this formula down even more by dividing 4 by 2. So now the formula is 1 plus 2 times n minus 1. And if we look at these 4 examples, we plug in the numbers to n for these formulas, and they all match to the results that we are expecting. So we want 1, 5, 13, and 25. And if we look over here, we have 1, 5, 13, and 25. So as long as we use this formula, then we can get the result. So the time complexity for using this formula would be O of 1. Because instead of looping through anything, we just plug in a formula, so the time will be constant. And the space complexity will also be O of 1 because we are not using any extra space. So now let's get to the coding part where we are just basically returning the formula in one line. So we will return the formula, which is 1 plus n times n minus 1 times 2. All right, let's see if it works. Okay, perfect. Hope this was helpful. I thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.